All right, welcome back, everybody. Today we're going to talk about section 6.1, the law of signs, and today we're going to focus on what we call the ambiguous case. Now, we call it the ambiguous case because in certain situations, it is possible that there may be more than one triangle at hand, and it's possible that there might not even be a triangle that exists at all. Our objective today is that you're going to be able to find the lengths of the missing sides and angles to triangles that do not have right angles by using the law of sign. We obviously started this one yesterday, and we worked with um, some relatively basic problems, basic in the sense of none of these had the ambiguous case potential. So looking here, we have a warm-up right away. It says solve the triangle that's given. We have that angle A is equal to 40 degrees, angle C is equal to 67 degrees, and side B is equal to 10. So first what I would do is I would start by drawing a quick picture. Remember, you can label your triangle in any order, so this could be A, B, and C. We know that angle A is 40 degrees, angle C is 67 degrees, and side B is 10 degrees. Now, in order to use the law of signs, I am going to have a relationship between an angle and a side. Presently, I do not have that in any of these situations. Those two, I just have the angle, but I don't know the sides. And then for B, I know the side, but I do not know the corresponding angle. So what we can do is we can use the fact that we know triangles have 180 degrees in them to sit there and solve for that missing angle B. And when I do that, I would come over here and I would take 180 minus the two given angles, minus 40 and minus 67. And when I do that, I'm going to find out that the remaining angle, angle B, must be 73 degrees. So I can already fill that in that is 73 degrees. Now, from there, we want to use the law of signs. So to use the law of signs, again, you want to use the relationship between an angle and the opposite side, and we can set up a ratio of 10 over the sine of 73 degrees. And we can set that equal to the ratio of any other sides. Now, in these other sides, we're currently missing the side length, so we're going to be able to solve for that side length by using this method. So I'm going to have A over the sine of 40 degrees. When I come over here to finish the problem, I would multiply or cross multiply these two things and solve. So when I do that and I simplify a little bit, I'm going to end up getting that we're going to have 10 times the sine of 40 degrees, and I'm going to divide that by the sine of 73 degrees, and that will tell me how long side A is. Now, that is just a calculator operation. You do want to make sure that you are in degree mode for this. And last but not least, I'll divide by the sine of 73. Excuse me. And I find out that side A must be 6.72. And we normally just round these to two decimal places like we learned yesterday. I will leave finding side C as an exercise for you. You guys can definitely pause your video right now and find that side as a little bit of extra practice. Now, in this particular problem that we were given, one thing to note about this one is kind of the pieces of information we were given. We were given an angle, a side, and another angle in this particular situation. And that's really important because an angle, a side, and an angle means that we're going to have no problems using the law of signs. It's going to work out the exact way we intend it to. In some situations, in what we know as the ambiguous case, we get an angle, a side, and another side, which we sometimes call side-side angle or angle side-side. Both of these are very problematic with the law of signs because multiple situations here can occur. Hence why we call it the ambiguous case. In one situation, our side lengths might not actually be long enough to form a right triangle or to form a triangle in general. In our second situation, our triangle actually might end up being a right triangle. We have a third situation in which there are two possible triangles. And then in our last situation, we could potentially have just one triangle. So when we're looking at the ambiguous case, what's really important to sit there and think about is the fact that this side length right here can essentially be rotated potentially into more than one position and still make this work. Since this would be our given angle over here and our given side right there, depending on how long this side length is, it might not even reach. It might reach down perfectly to where we have a right angle. it might need to swing backwards over to this position, or it might swing forwards into this position to form a triangle. Let's take a look at what this looks like. So we do have a couple of conditions over here for the ambiguous case. And those conditions basically are those same 4 cases that we talked about. Now, these get a lot easier to sit there and find when we actually get into a problem and look at one. So our steps to finding the second triangle, let's just hop into a problem. Here it is. Here's our situation. We're given an angle and 2 sides. Angle C is 33 degrees, angle B is 10, side B is 10, side C is 6. So in this situation, what I want to do is I'm going to come over here and first recognize the fact that I have an angle, a side, and a side, and that should immediately be raising a little bit of a red flag for me, that I'm going to sit there and I might be dealing with a problem that has the ambiguous case. Not every problem is going to sit there and be an ambiguous case problem. So for this one, I'm going to start by maybe just drawing a quick sketch of what this triangle might look like. So here's my triangle. If this is A, this is B, and this is C, we know C would be 33 degrees. We know that side B would be 10, and we know that side C would be 6. So in this situation, we do in fact have an angle, a side, and another side that's being given to us. So this is a situation in which the ambiguous case might be at play. So what we're going to do to solve this problem is simply this. We're going to start by finding one of the other missing angles in this problem. So we do already have side C and angle C, so we're going to set those up to use the law of sines to help us out. So I'm going to have 6 over the sine of 33 degrees is going to be equal to, the only other piece of information I have is side B here, so I'm going to set up B. So this would be 10 over the sine of whatever angle B is. Now in this situation, we don't know what angle B is. We're going to find that. So we will be using some inverse trig here to help us out. Now, in order to do this, we're going to first start by multiplying these two. So 10 times the sine of 33 degrees. And then that's going to end up being divided by 6 when we come over here to actually, hold on, let's just write this all out. So now we'll multiply these two. Remember, we set these up using cross multiplication. So this would be 6 times the sine of B. Then I would divide both sides by 6. And when I do that, that's going to leave me with the sine of B is equal to just 6. Now, this over here, officially speaking, is just a decimal. And we can get that decimal by using our calculator. So let's actually grab that decimal right now just for simplicity's sake. We're going to have 10 times the sine of 33 degrees. And that's going to be divided by 6 at the end of the day. So we're going to find out that this decimal, and we don't want to round this, is going to be 0.907731725, and that's going to be equal to the sine of B. Now this is what the sine of angle B is. What I really want to find out is I want to find out what angle B is. So to find out what angle B is, I'm going to do sine inverse of that answer that we just got. And that's going to tell me that angle B is equal to 65.19 degrees. Now, that is something that is not going to change for us. So down here in this angle B spot, we are going to write 65.19 degrees. Okay, now this is where we got to be a little bit careful. Since we're dealing with a triangle that is angle side side, we do know that we might have this situation in which there are more than one triangles, or maybe there's not a triangle at all. So there is an additional step that gets added. The step that gets added actually is going to happen right now. So the way we're going to figure this out is we're going to take 180 and we're going to subtract that 65.19 that we just found. So we're going to subtract our found angle. And when I do that, 180 minus 65.19, we get 114.81. Now, what we're going to do with that angle, so this 114.81, we're now going to add that to our original given angle. So our original given angle was this 33 degrees. So we're going to add this to original given. Angle. And we're going to see how big that number gets. When these two pieces get added together, this is going to tell us exactly what situation we're dealing with. So when I add these two together, I find out that these two angles together equal 147.81. Now, something to be aware of. This number tells us everything that's going on. If this number, so if this is less than 180 degrees, what that tells us is that we're going to be dealing with two separate triangles. And the way we're going to sit there and navigate that, since 147 is obviously less than 180, this 114.81, this is actually going to be the measure of the other angle B. So in these problems, when we find out there are two different triangles at play, what we're going to do is we're going to come over here and we're going to rewrite another row below this and say A prime, B prime, and A prime. So we just kind of copy those lines with the prime. The prime is going to tell us that we have more at play. I'll come find you in 2. I'm just recording a video. Thanks, Janelle. So our other angle here is going to be 114.81 degrees. Remember, this angle is that second, that B prime in this situation. And then from there, we're just going to sit there and solve as if nothing else special is going on. So angle C is going to be an angle that's going to be consistent throughout this entire problem. So angle C right here, so if angle C is 33 degrees and angle B is 65.19, then taking 180 and subtracting those two pieces would tell me that my missing angle would be 81.81. Now, officially, these two triangles here that we're trying to figure out are separate from one another. So in this situation, we don't ever use the piece of any information from one triangle to help us get to the other one. Now, likewise, angle C again is our given angle. So we can use that angle with this 114 to figure out what A prime is. So again, 180 minus 114.81 minus that 33 is going to give us 32.19. So now at this point, we have found the missing angles of both of those triangles. We just have two sides left to find. One of those comes from the first triangle, and the other one's going to come from the second triangle. So when I set up this first problem, I could sit there, and again, I can use the fact that I know angle C is this and side C is this, and I can say that 6 over the sine of 33 degrees would be equal to, now I'm trying to find side A, so I need to use angle A to do that. So side A over the sine of 81.81. And when I do that, what's going to happen is I'm going to have 6 times, remember this is that cross multiply and solve, so 6 times the sine of 81.81, and I'm going to be dividing that by the sine of 33 degrees. And when I do that, that's going to tell me that side A is really going to be 10.90. Again, that one we don't need to round up in this situation. For the last part of this problem, we're going to find the side A prime. So looking at A prime, when I get to that spot, I would set it up probably the same way. So again, I would use side C and angle C. So I would have 6 over the sine of 33 degrees. And then to find A prime, I'm going to need to use angle A prime. So A prime would be sine of 32.19. And then when we sit there and solve this, again, it's going to be 6 times the sine of 32.19. And I'm going to divide that by the sine of 33 degrees. And that's going to tell me that side A prime must be 5.87 in this situation. Now again, this was a situation in which we had multiple triangles. When we have multiple triangles, you are going to have to put in these lines down here on your own. I'm not going to tell you that there's going to be multiple triangles, but over here we can actually see a little bit of a picture as to how this triangle might actually end up looking for us. So with that being said, your job is now to actually go watch the second part of this video. Thanks for watching.